So in the morning, I was discussing about side distance, in that the first type of side distance, that is stopping side distance. So moving back to the next topic. So before that, I will try to discuss one example, and then I will move back to the another type, that is overtaking side distance. So as I discussed in the morning regarding this example, numerical example, that is, so that is stopping side distance at level road. So now moving back to the so this I've discussed. So stopping side distance this is the general formula you can come across. That is stopping side distance Vt plus V squared to F V square by 2GF. So this is a general formula, and here the design speed is in meter per second. So if you want a design, if the design speed has been given in kilometer per hour, capital V, you can make use of this formula. Okay, it is 0.278 into capital V into T, V squared divided by 254 into small f. And here I have explained you the conversion also here above. So you can just go through that. Here I will share you this note with you. So here this is the conversion. Actually, whatever the V into T is there, that has been converted to capital V into T. That is, V into T is nothing but a lag distance. So that conversion to capital V into T. So here also, here only you can see the conversion of small v into capital V. So small v into capital V, what you can see. So for example, if I remove this T on both LHS and RHS, if I cancel that, so small v is equal to what? Small v is equal to what? That is 1 divided by, that is 3.6 into capital V. So if you want to convert meter per second to kilometer per hour, divide it by 3.6. If you want to convert kilometer per hour to meter per second, then you multiply 3.6. So if you want to convert smaller to bigger, divide it. If you want to convert bigger to smaller, multiply it. So you can remember in that way. Because in this problem, you can see here the design speed for car 1 was given in kmph, and it was converted to meter per second by dividing with 3.6. And this all you have seen the example. I'll move to the next example without wasting much time. So stopping side distance at slopes. So at slopes, I explained you. At slope means you can imagine, like if you are not able to remember the formula, you can draw a straight road and with some inclined, so with some gradient, and assume that there is a vehicle moving on this gradient, and this vehicle is having some weight W, okay, and it will be having some frictional resistance opposing whenever it climbs a gradient, right? And that gradient, you can say it as n%. For example, 2%, in that way, 2% of gradient is there. So in that way, you can, n, and for example, for 100 meter, this vehicle has been moved on the gradient. So n by 100. So W, what happens whenever I say a vehicle, here you can just go through here, this one. So here a vehicle, you can see act with a weight of the vehicle as W, which is acting inclinedly. So that can be split into two, that is sine alpha and cos alpha, W sine alpha and W cos alpha. What is the sine alpha and cos alpha? So sine alpha is, that is what, n by 100, which I have explained you in the morning class. So you can just determine that, because lag distance will be same. Don't get confused with the lag distance. So lag distance remains same. So if I write SSD, so SSD is equal to lag distance plus braking distance. So lag distance is small v into T. That will be same for stopping side distance on level road and stopping side distance at slopes. But braking distance changes. So braking distance in case of SSD, so that here you can see that is V square divided by 2G plus or minus n%. or plus or minus n divided by 100. So this V into T lag distance remains same for SSD at level road, SSD at slopes. So moving back to this numerical example. So the question has been given calculating the stopping side distance on a highway at a descending gradient, of 2% for a design speed of 80 kmph. Assume other data as per IRC recommendation. So first you can write on the given data. So what is the given data? He has given us the capital V, that is 80 kmph, and he has given the gradient, descending gradient. Descending gradient means going down, descending gradient of 2%. That's why you have to write minus. In the question, he won't mention, he will just mention descending. Based upon that, you can give the sign plus or minus. For descending minus, for ascending plus. And also you can, if you need it, you can write it the terms of, that is 2 by 100, that is minus 0.02. Kanti, minus 0.02. And also, so these are the given data, and small g is 9.81 meter per second square. That will be a constant value. So, but what are the other data he has not provided? That is total reaction time. You can assume. So he said assume other data as per IRC recommendation. So total reaction time may be taken as 2.5 seconds, and the design coefficient as, or the coefficient of friction as 0.35. Why 0.35? Since he has given capital V, design speed as 80 kmph, and as the table I discussed earlier, for the vehicles with the design speed of more than 80, you can take it as 0.35. More than or equal to 80 kmph, you can take it as 0.35. So that's why I'm saying please go through the table. So the range of coefficient of friction is from 0.4 to 0.35, decreasing order with increasing speed from 30 kmph till a maximum of 80 kmph. So those are the assumed data here. So here what happened, they are converting it to meter per second. So small v is equal to 80 divided by 3.6. So 22.2 meter per second. So SSD on a road with a gradient is given in the equation. That's how, this is from the textbook actually, whatever the snapshot I've taken. So coming to the formula, SSD at slopes, right? Vt plus V square divided by 2G into F plus or minus n%. So V is 22.2, sorry, it is 22.2, don't get confused, it is 22.2 into 2.5 seconds, 22.2 meter per second into 2.5 seconds plus 22.2 whole square minus, sorry, 22 point whole square divided by 2 into 9.81, which is a G, and later on this is 0.35 into minus 0.02, minus 0.02, which is the gradient value, minus 0.02. Okay, so we'll get 55.5 meter is the lag distance plus 76.2 is the braking distance. So if you're getting confused, you can do separately lag distance and braking distance and add. So that will be the stopping side distance. So the total stopping side distance is 137.7, 131.7, or approximately 132 meters. So alternative way is what? He has given the design speed directly in kmph, right? So directly you can use this formula, 0.278 capital V into T plus capital V squared divided by 254 into F plus or minus 1.01 N into N. So 0.278 into 80 kmph into 2.5 seconds is the time. So plus here coming to this braking distance term, 80 squared divided by 254 into 0.35. This is into 0.35 into minus 0.05. So you can do this. So I'll move back to the rest. Next, coming to the calculate the stopping side distance. So remember here, always you try to take this minus 0.05, minus 0.02 correctly there. So here this textbook is confusing me, the screenshot. So here directly, so plus or minus is there, not into, sorry, I'm sorry here. So this is minus 0.02. So 0.35 minus 0.02 will be, so this total 254 into 0.33, 0.33. So similarly here also, here above also. So this completely will be 0.35 minus 0.02, which will be minus, sorry, it will be 0.33. So we'll get the stopping side distance at slopes, that is 132 meters, same. So you can take any of the formulas. So moving back to the next example. So this example is actually he has considered here the two cases here. Calculating the safe stopping side distance or just stopping side distance is all the same. Calculate the safe stopping side distance for the design speed, that is he has given 50 kmph for a first case. He is saying two-way traffic on two-lane road. Another is two-way traffic on single lane road. This is not plane, this is lane road, single lane road. And he has also given assumed coefficient of friction as 0.37 since it is 50 kmph, and reaction time of driver small t as 2.5 seconds. So coming to the stopping side distance, what is the formula? Lag distance plus braking distance. That is, lag distance is small v into t and braking distance is small v square by 2gf. Since here he is not mentioning any gradient, so whatever the SSD at level road, that equation can be taken. Since he has given capital V 50 kmph, so convert it into meter per second, or you can directly take the stopping side distance in terms of capital V. So T 2.5 seconds and G is 9.81, F is 0.37. So stopping side distance, that is 13.9 into 2.5, 13.9 meter per second into 2.5 second plus here 13.9 the whole square divided by 2 into 9.81 into 0.37, that is small f. So lag distance is 34.8, braking distance is 26.2. So adding both 61.4 meter is the stopping side distance. Okay. So next, first you determine the stopping side distance. Later on, we'll move on to the case, whatever they have given. So similarly, this is the alternative he has again explained here. Is explained here again. A, that is stopping side distance when there are two lanes. So when there are two lanes, so the two lanes 61.4 meter, because he has mentioned what two lane, that is two-way traffic on two lane. For example, if I draw a two lane, for example, this is a two lane, it has been divided by some center line. These are the two lane, and he is saying two-way traffic means there will be a vehicle from this side, vehicle V, and there also vehicle will be from this side, right? Two-way traffic. That's why, since the SSD whatever we are calculating is actually for two-way traffic, so whatever the stopping side distance we have got, that directly remains the same. But in the another case, he is saying stopping side distance for two-way traffic with single lane, with a single lane, two-way traffic on a single lane. Okay, so here what happens? On a single lane, what happens? There will be very congestion of a road. So what we need to do, we need to double the stopping distance. We need to double the stopping distance. So that's why single lane means, see, two lane means, so I can say this is 3.75 and this is 3.75. So total 7 meters, 7.5 meters is the total width of the pavement, right? So only single lane means only one lane, that is only 3.75. Only 3.75 single lane, only 3.75 with a center line. See here, he has mentioned two lane, but he has not mentioned that it is a divided or undivided. Don't worry about that. So just remember, two lanes means each lane 3.75, 3.75 means width of the pavement, width of the road or the width of the pavement is more. That's why stopping side distance remains same. But when the width reduces, stopping side distance should be increased for more safety or no collision happens. So that's why he will do 2 times of stopping side distance. So that will be 2 into 61.4. That will be equal to, sorry, this is equal to 122.8. So the total stopping side distance will be 122.8 for two-way traffic with single lane. But two-way traffic with two lanes, the stopping side distance remains same. So this type of questions they may ask. Okay, so try to go through this. I'll just go back to my presentation here. Yes, I'll try to show this stopping side distance equations again to you so that it will be a revision for you. So moving back to here, so this you can say it as stopping side distance at level road, SSD, lag distance plus braking distance. So this is the equation, Vt plus V square by 2GF. Okay, but if here the design speed is in meter per second, if the design speed is in kmph, if you want to take the design speed in kmph, or he has given the design speed in kmph, and if you want to use the same speed, you don't want to convert it into meter per second, then please try to remember this formula, that is 0.278 into capital V into T plus capital V square divided by 254 into F. Next, stopping side distance at slopes, which the numerical examples also have discussed. So this left hand side is completely the work done by the vehicle for stopping, work done for stopping of the vehicle, and this is kinetic energy of the vehicle. So by solving this, you will get the braking distance. So small v square divided by 2g into f plus or minus n divided by 100. Okay, so finally I can say, so this is the formula. Only braking distance changes in case of stopping side distance at a level road, stopping side distance at slope, but the lag distance remains same, that is small v into t remains same in both the cases. So v square divided by 2g into f plus or minus, sorry, this is plus s or minus, means f should be subtracted with the given gradient or added with the given gradient. You should add this f within the brackets whenever you go for an ascending gradient, whenever he say ascending gradient. But whenever he gives descending gradient in the question, try to subtract with the given friction value within the bracket.